Welcome to Module 2, Lesson 16, applying the properties of operations to multiply and divide rational numbers. This will be, I think, a very enlightening lesson because we are going to show how we could change everything into a multiplication problem. Okay, so we're going to take some division aspects of our problems and show you a way to turn them into multiplication, and therefore making it all easier because, as you know, many of the properties we talk about are applicable or do apply to multiplication and addition, as we talked about in the past, but not to subtraction or division. So by doing this, by changing, just like we changed subtraction into addition, we found sums of negative numbers, we're going to be doing something similar to that in this lesson. So yeah, bear with me, we will get there at some point, but first let's go ahead and do an integer, some integer fluency. So at the back of lesson 16 in your binder, there are two sheets. Again, it's integer division this time, and you turn back there, and I'll go grab mine. Okay, so here is integer division, and this is our round 1. And if you are ready, and if you're not ready, just go ahead and pause. But if you are ready, I'll be ready in a few seconds. I'm going to say, on your mark, get set, go, and then I'll start the clock for 1 minute. And you will try your best to do your best. Apply your negative and positive rules, and and do your best to divide. And these are just multiplication facts up to, looks like 13s. But the first few are not so difficult. Okay, so good luck. On your mark, get set, go. "30 seconds. "15 seconds. 10 seconds. 'And there we go. Okay, and stop. And okay, so go ahead and count up your number correct. Put it in the put it on the line there, and go ahead and get your turn over and get your round 2 integer division sheet. And we will go ahead and do round 2. Again, we're going to put our number correct and find our improvement. And again, that's what we're all about here, is improvement. And so get ready. On your mark, get set, go. "30 seconds. 15 seconds. 10. 0. Okay, thank you, and that's it. And if you'll go ahead and, again, write your number correct here, and then find your improvement here. Alrighty? Okay, so go ahead and do that, and let's get back to the beginning of our lesson. Okay, so here we are at the first page of your binder, and example 1 here says using the commutative and associative properties to efficiently multiply rational numbers. Okay, and this is the idea of efficiency, and it may not seem so efficient at times, but it is more efficient. You'll see that in in coming months and years, how what you learned this year, and if you do apply it, how doing math will become more efficient. So, and before you go ahead and evaluate this expression, okay, when you evaluate something, this term, this evaluate, what you're trying to find out is what all of this is equal to. Okay, so in a sense, I mean, it is an equation. You're trying to get to the point where you're going to have an equals at the end. So when you say evaluate, it doesn't mean like write a critique about it, but it means to go ahead and find the answer. Okay. Anyway, one of the questions I want you to consider, though, while you do this, or before you do this, actually, is will different strategies, if correctly applied, very important that you're doing everything correctly, result in different answers? So do you think you could do this in different strategies? But if you do, and they're both correct, will there be different answers? Could there be different answers in a perfect world? And why or why not? Okay, so just consider that, and we'll get back to that later after you do it. So go ahead and solve this or evaluate this expression, and come on back and try it different ways if you fancy. Okay, so here's the first way I did it, and pretty much this way of just kind of chunking it, just taking chunks at a time, moving pretty much. I was starting, as you can see here, with in the red up here, doing this point right here. What I've done is I've just taken -6 times 2 and turned it to -12 down here, and just kept everything else the same. Okay, so this is after my first step, look like that, and then after my second step, look like this, because what I did is I just took these two terms here, -12 times -2, I know that's a positive 24, and just made that, kept that there, and that was the last I did with that. And then this step here, and I could have actually done 24 times the -5 here, but what I decided to do was to do this the -5 and the -3, because they look a little more friendly to me. Now the reason I can do this is a property called the associative property, because it doesn't actually matter in math, in multiplication, what chunks I do. Okay, I can decide to do this chunk here, multiplication, multiply those. If these are all multiplication going across, I can multiply this chunk, I can multiply this chunk, I could have multiplied this chunk up here if I wanted to initially. Now instead of multiplying this chunk, which I could have done, the 24 times the -5, I went ahead and chose this chunk right here. Okay, this is all based on the associative property. Okay, somewhat, excuse me, somewhat related to commutative in the sense, but yeah, you can just move around. Okay, so, and in the end I come up with my answer of 360, because I got down finally to this step, 24 times 5. Okay, my next strategy, I just went ahead and I started off here with by applying my associative. Okay, because we always think of starting we always think of starting an equation or evaluating an expression from the beginning. Okay, in this case we're not. Alright, we're deciding to do this. Now, the reason to do, well, for me anyway, to do -2 times -5 first. First of all, it's going to yield me a positive number, which I like, and also it's going to give me a positive 10. 10 is a very friendly number. Okay, it's a great number to to actually multiply at the end of everything, which is why in this second step right here, what I went ahead and did is I took that 10 and just moved it, and again using my commutative property here, I moved that 10 to the end. That was going to be the last thing I was going to do, and at the same time I went ahead and moved my -3, moved that over here next to my -6, okay, because I thought that was a very friendly number as well. Yields me 18 in my third step here, and then times 2, and then times 10. I know how to multiply the 18 times the 2, which is very easy, 36. Then I'm going to actually multiply that by 10, which is very easy. All I got to do is add a 0, and I get 360. Just like I got last time, same answer. Okay, just doing it different, moving things around in a different way. Now, let's go back to that question that I had asked earlier, which I've lost because I've erased it. But is it, do the different strategies yield different answers? And in this case, no, they didn't. All right, and why was that? Hopefully you know, and you're talking about it's the nature of multiplication. Okay, because the nature of multiplication is that you can move it willy-nilly, move it here and there, okay, and you know that you can, if it's all multiplication, you can do whatever you want to do first, and it doesn't really matter, okay, because order has very little to do with multiplication, as we know. Okay, let's look at B and C and D as well. I haven't written the answer down to D yet, but we can do that together. I don't really have a lot of room underneath there. So B asks, what types of strategies were used to evaluate the expressions? We talked about this already. If you want to write this down, if you really good for you to have it in your notes, and hopefully that is the case always. Yeah, we applied properties, okay, such as associative, okay, and commutative. Again, associative allowing us to use to figure out or get the product of two numbers in the middle of the problem before we did the first or the last. Okay, commutative again is just moving individual numbers around within the equation or the expression. Okay. Now C, I asked you, can you identify the benefits of choosing one strategy versus another? Well, I liked right here when I got the 10 by multiplying the -2 and the -5. Getting 10 in the second strategy made the problem simpler. And again, that's just one strategy that I used that I thought made it very easy. I do enjoy when I have two negatives to get a positive number, get as many positives as I can, okay, and that kind of goes along with actually D, and question D here asks, what is the sign of the product? Okay, we know it was positive, okay, we know it's a positive number, and how is that determined? Well, a way that you can tell is if you do look at the problem, the expression right from the beginning, you can notice something about the number of different negative values you have and different positives. So if you look at the negatives, you have 1, 2, 3, you have 4 different negative numbers, okay? And again, this is with all multiplication now. But if you have 4 negative numbers, you know that your result of 4 negative numbers is always going to be positive, okay? Because you already know that 2 numbers, so if I have -6 times -2, okay, that's going to be 12, okay? So any even number of negative numbers is always going to yield a positive, okay? And then I have that positive, which is going to continue the positive streak, all right? Because if you just went ahead and did this, you could just change something. For example, if you I could show you and prove this to you here, but if I made this 6 a positive 6, then I would have, positive 6 times 2 is 12, times a -2, that's a -24, times -5, that's going to be a negative 120, and then times going to be a positive 120, and then times a -3 is going to be equal a -360. Okay, because I have actually 3 negative values. Okay, 3 negative values are always going to yield me a negative number. And no matter how many positive numbers I multiply times that one negative number, never going to become positive. Okay, so again, that's one way to determine what the sign of a multi-step multiplication problem is going to be. Okay, I was going to show you something here. We have exercise 1, and exercise 1 asks us to find an efficient strategy to evaluate the expression and complete the necessary work. Now, the most efficient strategy from my point of view, now again, this idea of efficiency, for me is quick and a way I can be pretty sure I'm going to yield the correct answer, is this. Now, this is not necessarily the way I'd like you to do it. I'd like you to actually apply the associative property and commutative property. But for me, here's what I would do. Let's just follow along with me. So I know that I'm just going to actually decide these are all just positive numbers. I'm just going to use the absolute value of everything. 1 times 3 is 3, times 10 is 30, times 2 is 60, times 2 is 120. And I can just count up how many negatives I have. 1 and 2. I have two negative values here. Actually, I'm sorry, three negative values. So I know if I have an uneven number of negatives, I know my answer is going to be negative. Okay, so right away I know that. Let me just show you again so you don't have to rewind. Again, just assume, this is all multiplication, assume these are absolute values, everything is positive. Okay, 1 times 3 is 3 times 10, there we go, equals 30, times 2, I don't know why it keeps going out. Okay, well my thing just disconnected, so I'm not sure where we were here. But yeah, let me just start all over again then. Okay, I'll just show you here. I was just trying to show you this efficient way, not the way necessarily I want you to do it in terms of yeah. Anyway, so I did negative, and I'm disregarding negatives and positives right now, just going absolute value. So 1 times 3 is 3, times 10 is 30, times 2 is 60, times 2 is 120. And all I have to do now is, again, add up the negative integers I have here, and I have 1, 2, 3. And as I have 3 negative integers, that is an uneven number of negative integers. Therefore, I know it's going to be a negative number. Okay, but I don't want you to do it that way. Just something for you to be aware of, just so you can always check your answer. And if you feel confident about your multiplication like that, a quick way to check your answer in the end. But anyway, would you go ahead now and apply some associative and commutative property applications to this problem and figure it out? Come on back. Why don't we go ahead and have you do exercise 1, exercise 2, and then answer the question exercise 3 asks you. Okay, come on back and we can check your work against mine. Maybe different, but let's just see if you get the right answers. Okay, well here's what I did for exercise 1. I went ahead and just again, like I told you before, I like to get rid of the negatives as much as I can, and I did that right there. Got positive 3, and then I went ahead and did these two, got them out of the way, applied some associative property there, doing the end of the expression. Then I went ahead and commuted a few numbers, commuted integers, commuted my 10 and my negative 4, because I like to have 10 at the end, the last thing I do. 3 and a negative 4, of course, yields a negative 12, and then multiplying that by 10 is a simple problem, which gives me negative 120, which I had done earlier. Okay, so exercise 2, here's how I chose to do it, and it might have been, well, for me it was easy, but I mean it made sense, but it might not be the easiest way for everyone to understand, or the most efficient. But I went ahead and just commuted my two fractions over to the front. You can see the 1/3 and the 1/2. Kind of. Then I came up with my -1/6. Okay. Well, before that, I should just point out that I know that my answer is going to be positive. Okay. Just first of all, I like to check that first because I have two negative values. Okay. So I know my answer is going to be positive. So I can indeed ignore all the negative signs. All right. But I don't here actually, but I can. Okay. So so I go ahead and do that. I commuted those over there. I got the -1/6. And then I just, I have these numbers here, I have all these whole numbers, and I go ahead and, again, I could have made this a little bit easier, I think, but anyway, I went ahead and did the 8 and the 9, okay, that's -72, did the 4 and the -72, -288, alright, and then when I multiply fractions, I know what to do. I have my 1/6, and then times make that into a fraction, which is 288 over 1, which is 288 over 6, which is 48. And again, I know when I'm multiplying two negatives here, I know I'm going to have a positive, but I knew the answer was going to be positive. No matter, whatever I got, it was going to be positive. So I got 48, and I know that answer is correct. But I will show you another way, and I'll come back in a minute with another way. Okay, here's another way to do it here. Actually, this was the example they gave in my teacher's book. But they went ahead and they saw the -1/2 and whoops, let me do that. The -1/2 and how, okay, do that again. There we go. The -1/2 here, and they saw the 1/3, and they saw the relationship here because they commuted the 1/3 down here because they were going to use it with the 9, which is very easy, and they commuted the 1/2. -1/2 over here because they were going to actually apply it to the multiplication of the -8. And what they do, okay, so they just commuted those. And then they went ahead, so the 4 just drops down, and now the -4 times the -8, and again, which I love to do so much, is to get rid of those negative signs, but that's 4. Okay, and then we have 9, and then 1/3. Then I know 9 times 1/3 is 3 over here. And then 4 times 4 is 16, times 3 is 48. So, whichever works for you. You may have figured out a different way. One of the questions they do ask is, oh my gosh. Okay, I'm not sure if you can hear me, but my computer is again reconnecting. I'm going to, let's see. Okay, and the question they ask you down here, number 3, is what terms did you combine first and why? Well, for me, I just, when I first did it, I first combined the fractions because I just wanted to get them kind of out of the way and deal with all the whole numbers on their own, and then apply the fraction, okay, with multiplication, because multiplying fractions to a whole number, multiplying fractions with fractions is very, very easy, okay. What they did is they went ahead and took the 1/2 and the 1/3 and just wanted to multiply them by numbers that they were going to be evenly, come up with an even number. So what they wanted to do is in the end, get all whole numbers, okay. So either way is good, whatever works for you, whatever you find to be most efficient. Okay, and then exercise 4 here, it says refer to the examples and exercises. This is interesting because kind of asking what I had said before. I seem to be a step ahead of this program here, but do you see any easy way to determine the sign of the product first? And like I told you, like I had shown you, proven to you, if you have an even number of negative signs, you will have a positive product or positive result, and if you have an uneven or an odd number of negative signs, you will have a negative product. Okay, so hopefully you've seen that, and maybe you could even write that down here. Okay, maybe I'll write it down and then I'll come back and just have. Okay, so here it is, all written out. Maybe you want to pause and go ahead and write it yourself. But again, just to reiterate or restate, if you have an even number of negative signs in your expression, your product, and again we're talking about multiplication now, your product will be positive, while if the number of negative signs is odd, uneven, the product will be negative. Okay, and again, excuse me, we are talking multiplication here. So let's look at example 2 here. And it's about using the distributive property. Okay, the distributive property to multiply rational numbers. Now, if you don't know what distributive property is, I'm going to show you right now. Hopefully many of you do. Okay, so the first thing they ask you to do here is to rewrite the mixed number as a sum, and we've done that before. So let's go ahead and do that. We're going to do -6. I'm going to use this little thing for the times. I'm using the dot more often, you noticed. And then in the parentheses, I'm going to put 5 plus 1/3. Okay, so I've now rewritten the mixed number as the sum of its parts. Okay, and we've done that quite a bit. All right, then multiply using the distributive property, and what that distributive property says is that whatever this number is out here, okay, outside of the parentheses, you can very easily multiply this by multiplying the 6 times the first term and then the 6 times the second term and adding them up or summing them. Okay, now we have to take into consideration our all the signs that we are applying here. Okay, so we have -6, or our first step here is -6 times a +5. Okay, so that's going to equal a -30. Plus, and again we're talking about sums here, and then we're going to do -6 times 1/3 is a -2. Okay, -2. So what I've done is I've taken this expression here, turned it into this, which makes it much easier to figure out, and now I go and I have a -30 added to a -2, it's -32. Okay, so if so that's distributive properties. So hopefully you're going to get a little bit of help here. So hopefully you saw this distributive property as making the problem easier to solve. Okay, and it is going to be something you are going to see over and over and over again in algebra are problems that are going to employ or to use the distributive property. Okay, now I'm going to go ahead and we're going to do exercise 5 now, multiply the expression using the distributive property again, same idea. I just want to show you how this would actually more commonly be seen. You would actually see the 9 would be right in front of the parentheses like that. There would be no need any longer for a the x for the multiplication sign or the dot. Okay, you can use them. These are not wrong. They're not wrong to be written like this with the dot with the x or the dot, but you will see it commonly, more commonly like this in the future, in the near future. Okay. But again, if we're going to write this, we're going to go ahead and take this apart, taking the mixed number, take it apart into its two parts, its wholes and its fractions. It's going to look like this. So we have 9 again times -3 plus -1/2. Okay. I guess we don't really need this parenthesis really. Okay, plus -1/2. All right. So what we've done is we've taken, and again to be very careful because it's something we always want to remember, is that this -3.5 is actually -3 and -1/2 added together. Okay, the sum of. So if I go ahead and do this, I know 9 times a -3, a positive 9 times a -3 is a -27. I'm going to add that to 9 times a -1/2, which is 4.5. Okay, and then all I have to do is add those, and again I'm adding two negatives again, okay, which I ended up doing in the last problem, and that's going to equal negative 31.5. Okay, all right, so that's it. And again, being able to add these two numbers pretty quickly and easily is very, very important. Alrighty. Okay, so example 3, using the distributed property to multiply rational numbers. They're asking you to evaluate using the distributed property. Now, if you notice something here is that they have actually distributed it out already. You can see they have 16 times 3/8 and then 16 times 1/4. Okay, so what this could actually look like, you can actually put these together. You can have it, you could put 16, then you could just put it like this, times 3/8 plus 1/4. Okay, you can do that. Alright, and if you did that, then you can just go ahead and combine these fractions, just making like fractions, of course. You got negative 3/8 plus 2/8, because 1/4 is same as 2/8, and then 16, and then you just combine those, and that's a negative 1/8. Okay, and then 16 times negative 1/8, of course, is a negative 2. Okay, because 16 times 1/8 is 2. 1/8 of 16 is 2, and it's negative because it's a positive times a negative. But it's also negative because we knew right from the beginning that we had one negative number, one negative rational number there. So because it was an odd number of negatives, we get a negative result. Okay. Now another way to do it, though, is could have actually just used this distributive right here. Could have just, for what I was thinking, that you have 16, times a negative 3/8. If I just went ahead and did that, I know that's going to be negative 48 over 8, which equals negative 6. And then I have over here 16 times 1/4, because we're adding these. 16 times 1/4, which is very easy. I know that already is 4, so I just drop that down as 4. Okay, so I have negative 6 plus 4 equals negative 2. Okay, this will be a little bit quicker for me. I don't know, whichever way you like, whichever way you prefer. Got to know your fractions, though. Got to know them pretty quickly. Okie doke. So this example 4 here is going to see us using the multiplicative inverse, okay, or the reciprocal, the one that we have used before, and I know a few of you are so excited to know about. Okay, the reciprocal, we're going to see that come into play. Okay, I'm not going to do that again. All right, come into play and help us out. Okay, because if we know something. So here, for example, if we're looking at this example, my question to you would be, how is this expression different from all the previous ones we've done in this lesson? Okay, and you can see, you probably noticed right away that it involves division as well as multiplication. Here's a couple divisions. Here's multiplication. Okay, so it's multiple. It's got multiple operations here. So we have division and multiplication. Now, what we do know, and we've learned, hopefully, again, that's why this knowledge of fractions was so important coming into this year, that when we divide fractions, okay, we are, remember, multiplying by the reciprocal. Okay, so dividing, just so we remember this, dividing by a fraction is the same as multiplying by its reciprocal. So now knowing this could help make our lives a lot easier, and I'm going to show you how right now. Okay. So what they're asking you here to do is you're going to rewrite this expression only as multiplication and evaluate. Okay, and I want to go ahead and, if you want to just go ahead and do this by yourself and give it a whirl, just go ahead and pause and do it. I'd really respect that of you. But I'm going to go ahead and just show you how we can go ahead and do this right now and make it all that much easier. Okay. So the first thing I want to do then is I want to go ahead and change all of my fractions. And the fractions I have here, I have 2/3 and have 1/2. So I have a positive 2/3 and a negative 1/2. I want to go ahead and turn those over. I want to turn those over into the reciprocals. Okay, and I want to just change these signs from division to multiplication. So I'm going to have 1 times now 3/2. Okay, because it is a reciprocal of 2/3 times, keeping my -8 times 3 times 2, or sorry, -2. Make sure I have that. That's -2. Okay, so I've gone ahead and found the reciprocal of these two fractions and applied them down here. Okay, now I have all multiplication. I don't have to mess with any division. And why is that a good thing? I mean, it's a really good thing because multiplication is so easy. We can use the associative property, we can use the commutative property. With division we can't, okay? We were stuck. If we were here, we couldn't move that -1/2 just willy-nilly to up here because it would change everything. Okay, change everything. But now that we have all multiplication, we have the world open to us. Okay, so one of the first things, actually, while we're here, let me just stay here, just park here right now, and I'm going to park it. I'm going to put it in pause, and if you haven't done this already, go ahead and do it, and come on back. Okay, so here's what I did with this, and boy, sure looks messy, but hopefully you'll be able to do this and figure this out on your own and find your most efficient way. But what I went ahead and did is I went ahead and well, we talked about that. I've changed everything, of course, to multiplication by using the reciprocals where I had division, and then I went ahead and commuted. I commuted my -2, and actually brought it over to here. Actually, it was right here. It's not over there, actually, but -2, because what I wanted to do, I saw that if I multiplied this -2 times 3/2, that was going to be easy to convert into a whole number, because 3/2 times -2/1 or 2/1 is 3, or 6/2, which is also 3. So this becomes -3 here. And I had commuted the -8 over to here just to join it with its whole number partner here. Okay, and so then and so then what I did, I went ahead and did do this multiplication here within these brackets here, and I got -3, and eventually 1 times -3 is -3, and then I just went ahead and did this. I mean, there are other things you could do, but I went ahead and did this -8 times 3, which is -24. Multiply those and I get 72, and again I knew I was going to have an even number right from the beginning because I had two negative values, negative and negative, and I got my positive product. Okay, so the last exercise here of this lesson is exercise 6. So if you would go ahead and work this one out, and again, just first step, I just want to let you know your first step should be to change all of the expressions into multiplication, so you can go ahead and commute and okay, and so you can commute and do other things, whatever you need to do, move these numbers around to make them a lot easier to manage. So go ahead and do that. Come on back for the answer. Okay, so before I go, I can go ahead and look again at my 1, 2 negative terms. I know I'm going to have a positive outcome. So I don't have a positive outcome. Something went wrong, something went awry. Okay, so again, first step, change my division, which was right here, times, divided by 1/6 becomes times 6 right here. Okay, I commuted 10 over, because I know commuting 10 over with a decimal is a very, very good idea, because it allows, if I have a decimal with a tenths place only, it allows me to turn that into a whole number, which becomes right here. So 4.2 times -10 is a -42. Okay, and then I went ahead and did my -1/3 times 6. I know 1/3 of 6 is 2. Okay, but in this case it's -1/3 times 6, which is going to yield me a -2. So I have a -42 times a -2, of course, is a positive 84. Alrighty, there we go. Okay, so in summary, boy, I hope this was a content-packed lesson, I think, and I really love it. I loved it. I hope you guys got a lot out of it. Can learn so much from this. These are, again, concepts that we'll continue to revisit. Hopefully, many of you came into this year knowing quite a bit of this, commutative, associative, distributive, but the more you use it, the better you become at it. Okay. But anyway, here's our lesson summary here, and multiplying and dividing using strictly orders of operations is not always efficient. Okay, not always efficient. The properties of multiplication allow us to manipulate expressions by rearranging, regrouping factors that are easier to compute. Okay, where division is involved, we can easily rewrite division as multiplication using our reciprocal rule to allow us to use these properties. The signs of expressions with products and quotients can easily be determined by checking, we've talked about this over and over again, whether the number of negative terms is even or odd. If you have an even number of negative terms in any expression, it's going to be a positive result. If you have an odd number of negative terms in an expression, you're going to have a negative result. Okay. Again, some of those properties we talked about this time. We have associative, commutative, and a new one, hopefully not entirely new, but a new one that came up here was distributive. Again, just our initial introduction. Hopefully not initial for everyone, but initial for maybe some of you, and a reuniting for some of you with this word, distributed property. Okay? So yeah, there you go. Take your time, maybe go over this again. Finish up your exit ticket and your problem sets. The next thing you'll do is your mid-module assessment on your own at home. Use all the resources available to you, and come in at our next session ready to take an assessment very similar to that one in class.